This video presentation brings to you an overview of numerical methods and approximations. So yes, the course code is ET534. You have 3 credit points for the same. The scheme of instructions is as follows. You have 3 lectures, no tutorials and practicals. You have 25 marks for internal assessment, and your final term marks would be out of 100. So you have your total marks would basically be 125. So the concentration on this video would purely be where would you be able to use in terms of applications. All right, so where will you be able to use numerical methods? So before we actually begin, we need to understand what are the prerequisites with regards to numerical methods. So the prerequisites which you require are linear algebra, calculus, ordinary differential equations and partial differential equations, all of which you'll have worked with in your first semester, second semester, and probably even to a certain extent in the third semester. So computer software and languages that you would be interested in knowing to be able to implement these methods. All right, so one is you have MATLAB, you have Mathematica, you have C programming, and you have Python. Furthermore, what are the categories of numerical methods that you're going to be studying? So one is something called as error estimation. So given some kind of data, if there is an error in the data, you would be able to identify that error and make the required correction using a certain numerical method. Finding the roots of equations. So sometimes you have equations. They could be equations which involve trigonometric functions or exponential functions. So come what may, you would be able to use a numerical method to find the roots of equations. Besides which you are able to solve a system of equations. You all have learned to solve a system of equation using matrices. So that's something you are going to be able to revisit in this course. Next, you have numerical integration and differentiation. Now, this is something which is going to be very interesting for you because when we look at analytic solutions of integration or differentiation, sometimes students do find it hard to get an answer analytically for a particular integration problem. So numerical methods offers you approximate methods which will help you to solve an integration as well as differentiation. All right. So that's with regards to numerical methods. So what exactly is numerical methods? If you look at numerical methods, it's really a part of numerical analysis. Okay, and numerical method is basically a mathematical tool which will help to design to solve numerical problems. So you would want to understand these numerical methods in order that you're able to analyze certain amount of your data, which you will be probably using in real world analysis. Okay, so that's with regards to numerical methods. So obviously the first question would be where do I use these? So here you have a few applications. So one is development of mathematical model representing all important characteristics of the physical system, solution of governing equations, critical load for buckling a column, static analysis of scaffolding, analysis of natural frequencies of a vibrating bar, stability of frameworks under external forces, bridges, houses. More importantly, you have mostly numerical linear algebra, sometimes differential equations, and so on. In hydrodynamics and aerodynamics, construction of cars, planes, boats, usually you will have partial differential equations with finite element methods, vibrations of steel and concrete construction. In computational fluid dynamics, you have computational mechanics, finite element method. In structural analysis, furthermore, we have a few more applications. So here we see in coal power plant for the modeling of combustion flow, structural mechanical analysis, communication power, groundwater and pollutant movement, solving practical technical problems using scientific and mathematical tools, airflow patterns in the respiratory tract, transport and disposition of chemicals through the body, re-entry simulations for the space shuttle, modeling of airflow over airplane bodies, design and analysis of control systems for aircrafts, forecasting and predicting in the field of machine learning. So you also will see a lot of it in data analysis, right? Okay, so what is the scope? Most definitely research. And I believe even if you want to get into your industry, you will want to research on certain things, because eventually as engineers you want to also provide to society. So yes, research and of course innovation, right? So that's your scope there. Um, so when you're learning this course, you all are going to be learning numerical methods, which is part of numerical analysis. And once you learn numerical methods, if you take on the interest, you will want to eventually probably start learning more on numerical analysis. So for your course with regards and specifically to numerical methods, the following textbooks will basically be used. So you can have a look at the textbooks. You have certain reference books. Well, there are more reference books and textbooks that you can refer to. And eventually during the course, we will also be providing you with research articles and research papers in which numerical methods or numerical approximations have been used. So that will give you a better overview of where and how you can go ahead with numerical methods accordingly, right? So yes, I wish you all the best, and I would like students to remember one thing, mathematics is a game. Once you master the art of playing the game, you become a star player for life. So you need to take your knowledge of mathematics and make a difference in your career. Innovate and create. Society needs you. So I wish you all the best. Looking forward to teaching you numerical methods and approximation. Thank you.